Hello, CEP 637. So today we're going to go through the assignment 7. Um, Assignment 7 is a little different than the other assignments because I'm asking you to use this process tool, which is an add-on to SPSS that allows for the testing of moderation and mediation effects. Assuming that you have the process tool installed, which there is a page in your book that describes this, let me know if you had struggles with this part. Here was the specific assignment details. To continue using the recoded data set that I uploaded, and you need to examine the question: is there a moderation effect of ESCS, which is PISA's measure for socioeconomic status, on the relationship between opportunity to learn and mathematics achievement? And if so, what does the effect look like? So, use the process tool to examine if a moderation effect exists. Make sure to use the recoded version of opportunity to learn, which is dichotomized. Remember to put ESCS, the anticipated moderator, we don't know if it is, we're testing to see if it is, in the box for moderator, which is marked W. And then check the following options: generate code for visualizing interactions, choose the standard deviation values under the heading conditioning values, and select the Johnson name and output, which helps to understand at which point things become statistically significantly different based on different levels of the potential moderator, in this case SES. Some things to examine after doing that from the output is the interaction term statistically significant, which this is the same output you would get if you did a multiple regression with an interaction term that you would have to compute a variable for. What does the R-squared value tell you about the interaction term? And does the relationship between opportunity to learn and math achievement change across different levels of ESCS, and how do you know, and for which values might the relationship be different? Okay, so if we go to SPSS, so we're going to go to Analyze. We should see the option here, and we're going to go with version 3.4. I have a previous version installed here. You will not see that on yours. And then we're going to put that y variable here. ESCS is the potential moderator, so we're going to put it in this box here. And then we're comparing on opportunity to learn, and we're going to use this one, opportunity to learn, and this is particularly for an applied math problem, and there is a description we can look at for that later to help interpret that. Under options, and for some reason this keeps opening on my other screen. We want to generate code for visualizing interactions. Just in case it might work for you, I noticed that depending on what version of SPSS people had installed, it appeared that this code sometimes didn't work. We want to see this be the standard deviation values, and we want to look at the Johnson name and output. Click continue, click OK. And let's take a look at this output. So under here it still says running. If you notice in the bottom, I'm going to wait a second for this to run. And it is getting bogged down here, but remember, it is also running several hundred times. Okay. So, see here, model 1, X, Y, and W, or sorry, Y, X, W. Sample size total was 41,708. That's actually pretty good. And we know most people have an ESCS value. Everyone has a PV1 math value. So this is really being limited mostly by the opportunity to learn variable. Model summary, the total R squared, 0.2238. It's not great, but it's not horrible. We see that the overall model is statistically significant. Here are the coefficients for these variables. Opportunity to learn, ESCS, and INT1. That does not mean intercept. The intercept is the constant row. INT1, if you look down here, is the interaction term produced by opportunity to learn multiplied by ESCS. You can see that opportunity to learn by itself is almost not statistically significant. The impact is very small and the confidence interval goes almost down to 0. Or I should say almost up to 0. It has a negative impact. But the interaction term is statistically significant. Still has a pretty small effect on math scores. We can see that the interaction term x times w has an F-score of 41, or I should say the change in the F-score of 41 points, and is statistically significant. But look at the R-squared change. It is adding basically 0.08% additional variance explained. Not very much. The statistical significance is probably likely due to the high sample size. The conditional effects, you can see here's 1 standard deviation below, 1 standard deviation above. That's what we told it to do. And it looks different because it wasn't standardized. We should have told it to go ahead and center these variables. But this is the mean. So 1 standard deviation below is negative 1.5. 1 standard deviation above is 0.9496. So at those different values, it is statistically significant on both ends, but not at the average itself. So at the average SES, we don't see a difference in students' math scores based on how much opportunity to learn they had, whether they had at least some or none, or rarely had the opportunity, I think is the word that was used. And the effect is very similar at both sides. Going 1 standard deviation above an SES actually appears to be having a negative impact. And remember, the opportunity to learn here was in solving a simple 2-step equation. So when you're solving a 2-step equation, it looks like the effect is is negative, which means the higher SES you have, the smaller your score is, the lower your score is. And then we see that at the values of negative 0.8 and negative 0.036, both of those are sort of straddling this average score of negative 0.29. So negative 0.8 is between this negative 0.29 and the negative 1.5, and the negative 0.036 is between the negative 0.29 and the positive 0.94. No, I take that back. No, that's right. Yep. So it's even tighter than that, and it's showing you that the percent below this negative 0.807 is 32% below it, and we can see that it becomes statistically significant as the value of SES decreases, and as it increases from this average SES value. So I'm assuming that probably below that value it is statistically significant, and above this value it is statistically significant. And if you look at that, that's about 85% total. So there's about only 15% of the population that where it is assumed to not be a statistically significant difference, hovering very close to this average SES range. And of course, if we look here, SES, statistically significant, all the way down to this 0.05, which is the negative 0.8077 value that we saw there. So that's the point at which it's no longer statistically significant, but less than that, it is. Above that, it is not until it reaches the next value, negative 0.0306. And then after that, it becomes statistically significant again. So if we think back to the instructions here, is the interaction term statistically significant? The answer to that is yes. We saw that there was a statistically significant difference here. The interaction term is statistically significant. We can also see it here in the model summary or in the model coefficient table. It had a statistically significant coefficient, and it statistically significantly improved the model, even though that impact is very, very small. What does the R-squared value tell you? That's what we just talked about, that the impact is very small, only adding an additional 0.08% change. And then does the relationship between opportunity to learn and math change across different levels of ESCS? How do you know and for which values? And that's where we're really looking at this values here to help us understand that. Below this value and above that value, and we can see it here. That's how we know it's above and below. So here's where it hits 0.05, and in between that one and this one here of negative 0.0306, that's the zone of not statistically significant, and everywhere else it is statistically significant. And we'll have another video later to talk about how to create a nice plot in Excel that will help show what this looks like. That might be useful in, say, a final project if you were going to do this in your final project, or in just a manuscript for a journal article of some kind. All right. And that is it for this walkthrough video.